Our lesson for today is all about addition and subtraction of radicals. In adding or subtracting radicals, it is like adding or subtracting variables. The variables must have the same terms, and in the radicals must be like radical. When we say like radicals are radicals with the same indices and same radicand. While on the other hand, if the radicand are not the same, then the radicals are unlike radicals. So we have four rules in addition and subtraction of radicals. Our first rule is square root of a plus or minus square root of a is equal to 2 and square root of a. Since they are like radicals, we can add or we can subtract the two given. Next rule, we have square root of a plus or minus square root of b is equal to the square root of a plus or minus square root of b. Since they are unlike radicals, they will retain. We do not add or we do not subtract them. Next, for our third rule, we have cube root of a plus or minus square root of a is equal to the cube root of a plus minus square root of a. They are also unlike radicals and they will retain because since they have the same radicand but they are different in their indices, which is 3 and 2. So we cannot add them or we cannot subtract them. Next, for our fourth rule, we have square root of 2a plus square root of 8a. So we can find the factor or we can simplify the second given, which is square root of 8a. So it will become square root of 2a plus or minus square root of 4 times 2a. Since if you factor the radicand, if the radicand is not a perfect square, make sure that one of the factor is a perfect square. So for the factors of 8, we have 4 times 2 and 4 is a perfect square. So we can write that as square root of 2a plus or minus now 2 and square root of 2a because we simplify the square root of 8a. So now since they are like radicals, then we can add the 2. So square root of 2a plus or minus 2 and square root of 2a, we will have now 3 and square root of 2a because we add the 2 like radicals. So that are the rules in addition and subtraction of radicals. So now, to easily understand if the given are like or unlike radicals, let's have an example. So for number 1, what do you think will be the answer? Is this like or unlike radicals? The answer is they are like radicals because they have same index and the same radicand. Next, for number 2, what will be the answer? The answer is unlike radicals because since they have same index but they are different radicand. Next, for number 3, what will be the answer? So the answer is like radicals because they have the same index and the same radicand. Next, for number 4, we have cube root of 7x and square root of 7x. What will be the answer? So the answer is unlike radicals because they have the same radicand but they are different indices, which is 3 and 2. So now you know how to differentiate what is the difference between like and unlike radicals. So now you need to follow the rules and proceed to the instruction. So let's have an example. So for number 1, we have 3 and square root of 2 minus 5 and square root of 2. Since they are like radicals, we can minus the 2 given, or the 2 terms. So the answer for this is negative 2, because we subtract our numerical, which is 3 and 5, and then copy our radicals. So we have now negative 2 and square root of 2. So that is the answer for number 1. For number 2, we have 2 and square root of a minus square root of a plus 3 and square root of a. What will be the answer? So if you encounter square root of a and there is no numerical beside the radical number, there is a numerical which is 1. So now, let's proceed to the operation. So 2 minus 1 is 1, plus 3 is 4. So we just focus on the numerical term. So we will have now 4 and square root of a. So the answer for number 2 is 4 and square root of a. So just remember, class, that if the radicand and indices are just the same, we can add or subtract. And in terms of the radicand, we just copy only the radicand. When we say radicand, that is the term inside the radical sign. Next, another example. So 6 and square root of 3a minus 2 and square root of a plus square root of 3a plus 5 and square root of a. So what are we going with this? So 6 and square root of 3a and square root of 3a can be combined. And also, so if we combine that, we will have now 7 and square root of 3a. How did we get 7 and square root of 3a? We all know that there's a numerical in the square root of 3a, which is 1. Next, and also we can combine negative 2a, negative 2 and square root of a, and positive 5 or 5 and square root of a. So we will have negative 2 plus 5, we have positive 3 and square root of a. Now, since they are unlike radicals, they will retain. So therefore, the answer for number 3 is just 7 and square root of 3a plus 3 and square root of a. Now, let's proceed for our last example. So square root of 8 plus square root of 8 plus 3 and square root of 8 plus square root of 18. So as you can see, we can combine square root of 8 plus square root of 8 plus 3 and square root of 8. And we all know that square root of 8 has there is a numerical which is 1. So let's focus on our numerical. 1 plus 1 plus 3, we will have 5 and square root of 8. And then let's bring down plus square root of 18. So by applying the laws of radical, or the second law of radical, since 8 and 18 is not a perfect square, we can factor, or we can find the factor of 8 and 18 by in which one of the factor is a perfect square. So the factor of 8 is 4 times 2, and the factor of 18 is 9 times 2. So if we apply the second law of radical, we can write this as 5 and square root of 4 times square root of 2 plus square root of 9 times square root of 2. And since square root of 4 or 4 is a perfect square, we can remove that, or we can remove 4 to radical sign. So it will become now 2. And we can remove also 9 out of the radical sign. It will become now 3. Or it will become now a whole number. So again, for our 5 and square root of 4, it will become 5 times 2. Where did we get 2? Just that is the square root of 4. And then multiply square root of 2. And x plus 3 and square root of 2, because 9 because the square root of 9 is 3. So therefore 5 times 2 is 10. So we will have now 10 and square root of 2 plus 3 and square root of 2. Since they are now like radicals, we can add now 10 square root of 2 and 3 and square root of 2. And therefore, the answer is 13 and square root of 2. So I hope you understand our lesson for today, which is addition and subtraction of radicals. Thank you for watching.